This is video 1 of the cross product, and in this video we'll discuss how to take the cross product of two vectors and properties of the cross product. A determinant is a number assigned to a square array of numbers in a certain way. In Calculus 3, we use the determinant to calculate the cross product of two vectors. First, we need the determinant of a 2 by 2 matrix, where our matrix is A, B, C, D. And what we do is we multiply down the forward slanting diagonal. So we're going to do A times D. And then we do the backwards diagonal, B times C, and we subtract. So you end up with the determinant of matrix A, B, C, D is AD minus BC, forwards diagonal minus backwards diagonal. A 3 by 3 matrix is what we really care about. So to take the determinant of a 3 by 3 matrix, where our matrix is top row A1, A2, A3, middle row is B1, B2, B3, and bottom row is C1, C2, C3, we're going to do what we call expanding along the top row. So we start with our first entry in the matrix, A1. And A1, we're going to eliminate the row and column that A1 sits in and look at the resulting 2 by 2 matrix. So we have the matrix B2, B3, C2, C3 left over. So we'll have A1 times the determinant of that 2 by 2 matrix. And notice that the sign of A1 did not change. We just have A1 listed there. Now we expand to A2, and we use the opposite sign. So it's minus A2 times the matrix that results when we eliminate the row and column that A2 sits in. So what we're left with is the 2 by 2 matrix B1, B3, C1, C3. Next we expand to A3, and we're back to addition, plus. We eliminate the row and column that A3 sits in, and we're left with the 2 by 2 matrix B1, B2, C1, C2. And then we use our definition of 2 by 2 determinants to finish off the determinant of the 3 by 3 matrix. So we ended up with the determinant of the 3 by 3 matrix was A1 times the determinant of B2, B3, C2, C3 minus A2 times the determinant of B1, B3, C1, C3 plus A3 times the determinant of B1, B2, C1, C2. So we can use this definition now to define a cross product of two vectors. The cross product of U, where U is the vector U1, U2, U3, and V, where V is the vector V1, V2, V3, is U cross V equals the determinant of the 3 by 3 matrix created by putting ijk in the top row, where ij and k are our unit vectors, vector u as the second row, so u1, u2, u3, and vector v as the third row, v1, v2, v3. So then we want to expand along the top row. So we have I, our first entry, times the determinant of u2, u3, v2, v3, which would give us, if we do our forwards diagonal minus backwards diagonal, we get u2, v3 minus u3, v2. And then remember, signs alternate, so I'm going to do minus j times the determinant of u1, u3, v1, v3. So doing the forwards diagonal minus the backwards diagonal, that becomes u1 v3 minus u3 v1. And now we're back to a plus, so I do plus k, and the 2 by 2 matrix left over is u1, u2, v1, v2. So this is forwards diagonal minus backwards diagonal, so k times u1, v2 minus u2, v1. So that's the cross product of two vectors in 3 dimensions. And we're going to see a lot of applications of this in coming videos and throughout the term. One really important fact about the cross product is that u cross v is orthogonal, or normal, meaning 90 degrees, to both u and v. This is going to be really important when we get into section 11.5, where we talk about planes. And we have this thing called the right-hand rule that says that if you use your right hand to scoop from u to v, it tells you which way the cross product is going to point, whether it's going to point up from your plane or down from your plane. And remember, our planes can be tilted in space, so that could be like left from the plane or right from the plane. And if you scoop from v to u, you end up pointing in the opposite direction. So what we can see from this right-hand rule is that u cross v equals negative v cross u. This is really important as well because you get an opposite signs if the order is switched. So u cross v and v cross u are not the same, they're opposite signs. So let's do an example where we want to find a vector normal to u equals 1, 1, negative 1, and v equals 2, 4, 6. So remember what we just went over. U cross v is normal to both u and v. It makes a 90-degree angle to both vectors. So all we have to do is take the cross product of these two vectors. So we have u cross v equals the determinant of the matrix ijk, 1, 1, negative 1, and 2, 4, 6. Remember, that's ijk in the top row, u in the second row, v in the third row. Okay, so also remember our signs alternate as we expand along the top row. So we're going to start with I, and then if we eliminate the first column and first row, we end up with the 2 by 2 matrix 1, negative 1, 4, 6. And then minus j, eliminate the first row second column, and we end up with the 2 by 2 matrix 1, negative 1, 2, 6. Plus k, eliminate the first row and third column, and we end up with the 2 by 2 matrix 1, 1, 2, 4. Now we want to actually finish this off. So we have I, and then determinant of the 2 by 2 matrix 1, negative 1, 4, 6. We go forwards diagonal minus backwards diagonal, so 6 minus negative 4. Minus j, forwards diagonal minus backwards diagonal, so 6 minus negative 2, plus k times 4 minus 2. Now we just simplify the numbers to get our vector, and we have 10i minus 8j plus 2k. Now notice that your result for the cross product is a vector. When we did the dot product, we got a scalar, but when you do a cross product, you get a vector. That's really important to remember as you go through the course. Okay, and lastly for this video, properties of the cross product. Our first property is RU crossed with SV is equal to RS times U cross V. So R and S are scalars. So it's saying if you have a scalar times U crossed with a scalar times V, then you can pull those two scalars out front and just do the cross product and then multiply through with the scalars. We also have distribution over addition. So U cross parentheses V plus W equals U cross V plus U cross W. We also have backwards distribution. V plus W crossed with U equals V cross U plus W cross U. So we have left and right distribution over addition. Now that third property I skipped over, V cross U equals negative U cross V, we talked about that on a previous slide. If you switch the order, it switches the sign. And then our fifth property here, 0 crossed with U equals 0. And I'm talking about the 0 vector, not the 0 scalar. And the last one, U crossed with parentheses V cross W equals U dot W times V minus U dot V times W. So remember, the dot product gives you a scalar, so it's a scalar times V minus a scalar times W as your result. So these are the 6 properties of the cross product that you'll need to know.